Okay. Hello everyone. Welcome to the video lecture, the live lecture on vector spaces. So today I will be continuing the discussion further that we had taken up for the vector spaces here. Okay. So we had discussed how to check whether a vector space is linearly independent or dependent. So that we will see how to work around it, and we will uh, discuss the further topics today. Hello to all of you, those who are joining. Yeah, so I will be discussing this. सो लेट अस स्टार्ट. अभी शुरू करेंगे फटाफट क्योंकि बाद में समय कम मिलता है, तो फटाफट यहाँ पर इसको ख़त्म करते हैं और स्टार्ट करते हैं. चलो, तो आज हम वेक्टर स्पेसेस का दूसरा हिस्सा देखेंगे कि हम लोगों को बेसिस कैसे कैलकुलेट करके मिलता है. तो नाउ व्हाट इज़ बेसिस, ये पहले देख लेते हैं कि बेसिस क्या होता है. बेसिस ऑफ अ वेक्टर स्पेस के बारे में बात करेंगे. तो इसमें सबसे पहली चीज़ है कि बेसिस एक सेट ऑफ वेक्टर्स होता है. सो व्हाट इट इज़, राइट. सो कंसीडर सेट ऑफ वेक्टर्स. कंसीडर अ सेट ऑफ वेक्टर्स, लेट्स से बी, इसको नाम देते हैं B1 B2 B3, ऐसे अप टू कोई तो सेट होगा. फाइनाइट लेते हैं हम, Bn बी a finite set of vectors from the vector space V, then the set B is called a basis, is called a basis of vector space V if the condition is here, the first condition is that the set of vectors, or the set of vectors in B, or the vectors in B are linearly independent. So the vectors B1 comma B2 up to Bn are linearly independent. This is the first thing. Hello, those of you who are joined, please mark your presence by putting hi, hello, or the greetings of the day. And greetings of the day to all of you for joining in on a Sunday afternoon. It's generally a siesta time, but we are working hard towards our goal. And happy Ram Navami to all of you, and enjoy the day in the bliss of mathematics and the Lord Ram. Okay, so the vectors B1, B2, Bn are linearly independent, and the linear span and the linear span of the vectors in B is V. Okay, or it means and any vector can be written as a linear combination and of, that is what it means here basically. It means that any vector in V can be written as the linear combination of vectors in B. Okay, so all the vectors are to be taken. It is not there that one vector. Hello. Yeah, so that is what is there. Now let me just help you out that you what are the bases. So there are some small results related to bases. I'll give you. I'll just put this thing here. Okay, now some result number one. Result number one, the first result is the if V is a finite dimensional vector space, okay, or rather you can call it like this. It would be great if you write like this way. Just a minute, I'll give you the result, but let me reframe it properly. So the thing is that if B is a basis of V and B has B1, B2 up to Bn vectors, then dimension of V is equals to n. Okay, that is what it means. So number of linearly independent vectors in the basis represents the dimension of the vector space V. Okay, now one very important theorem is there, that if B equals to B1 comma B2 up to Bn are the basis vectors, like, or is the basis set, is the basis of V, then B union with any another vector u1, okay, where u1 belongs to V, u1 belongs to V, the set u1 belongs to V is a linearly dependent set. This is the first two result. Okay, third result is the set of vectors in basis B is not unique, is not unique, okay, this is one thing. Another thing is that um, yeah, any set containing containing 0 bar, the 0 vector, okay, 0 vector cannot be a basis set, cannot be a basis, not be a basis of V also, because or rather because that set is linearly dependent. Another thing what is there is every vector space has basis. Finite or infinite, we are not bothered, but these are the result which help you down, okay. So these are the things. So I hope all of you all are there, and you people are able to follow this. These are the results. I'm not taking any question right now, so question now, after a few minutes I'll start. Okay, so um, here we have vector spaces and the bases. So the see, once there was a question that check whether the following vectors are bases or not. So let us see whether this set of vectors form the basis or not. Yeah, it's very um, humid over here where I'm sitting, and so I'm already dried, so I'm drinking water. Okay, so yeah, so let us see, check whether the vectors is a basis or not. So is a basis or not. So first is we are given, let's say b is b1 equal to 1 comma 2 comma 3, b2 equal to 1 comma minus 2 comma 1, and b3 equal to 0 comma 0 comma 2. So we have to check whether this is a basis set or not. So let us see whether this will become a basis or not. So first thing, see, if you are a mathematical uh, if you are a mathematics student or a non-mathematics student, the technique is one and the same. You will have to use the advanced ways to understand the concept. Linearly independent also has notions, connotations with determinant. So what is the thing you need to see? So see, obviously the vector space V is going to be R3. Okay, all are from the real numbers. So now what we are going to check, so we have to first see they are linearly independent or not. To check whether b1, b2, b3 are linearly independent or not. So if you have to do this, what you do is consider the determinant. Consider the determinant of b1, b2, b3. So what you do, you write all the three vectors in column. Okay, so 1 2 3, 1 minus 2, 1 and 0 0 2. Okay, here you have written. Now you calculate the determinant of this matrix. This determinant you calculate. So what do you get over here? Let me know. So it's going to be, the answer is going to be 2 times minus 1 to raise to 3 plus 3 is 6, and 1 2 1 minus 2. Okay, that's the determinant. So 2 into 1 and minus 2 minus 2, that is going to be minus 4 minus of 8, which is not equal to 0. Okay, so here we say determinant of b1, b2, b3. You calculate the determinant whichever way you know. Okay, you can use your calculator if it is allowed, or you calculate manually, whichever way you know. So here it is not equal to 0. Hence b1, b2, b3 are linearly independent. Okay, are linearly independent. Now note dimension of V is 3. So we need 3 linearly independent vectors to span R3. Okay, V equal to R3, right? Here it is V equal to R3. Hence the given vectors, hence B equal to B1, B2, B3 is the basis of V. This is what you can do. Alright, so this is what you need to write in the exam. So the span is a different thing, but what does it mean is to show that all the vectors are can be written as a linear combination of these three vectors. So it is finding them, it is okay. If you do not do too much of excavation, that's okay, but this you can write. Okay, so here it means, that is for span it means you need to write let u equal to u1, u2, u3 belong to R3. Okay, so all the vectors u equal to c1 b, let's say some constant alpha 1 b1 plus alpha 2 b2 plus alpha 3 b3. they can be written like this. So what are we now trying to say, that we can always find some constants alpha, so that all the vectors in uh, R3 can be made up of these three linearly independent vectors. So this is what the span talks about for span. So you can avoid this, but it's okay if you write this. This is also okay. So for span over here. So now let us take up the next question and see what happens there. um, yeah, so let's see. Another set is there. B equals to, let's say, 1 comma 2 and minus 1 comma minus 5. Okay, is this a basis? Okay, and the V is equals to R2. Check. B is basis for V equal to R2 or not. Okay, so how do we check this? So checking here, it means again we will have to calculate the determinant. So consider the determinant. You write them in the column manner. Consider U equal to 1 comma 2 and V equal to minus 1 minus 5. So determinant of U and V is equals to, so U and V determinant is 1 2 minus 1 minus 5, which is not equal to 0, right? Obviously this determinant is not equal to 0, therefore U and V are linearly independent. Okay, understood this, how to show something is linearly independent? Okay, now there is one concept of Wronskian is also there, but let's see whether they ask it or not. That's the only problem. If they don't ask and unwanted, if we go about it, I'll just guide you through that, and if it is there, then it would be good that you people know about it. Okay, so yeah. Now another thing, what is important that comes our here. Let's say, suppose you are given, suppose that U equal to 1, V equal to X, and W equal to X square. These are the three vectors given to you. Okay, these are the vectors now, and the are the um, are the vectors from vector space P P2 x. Okay, P2x, the polynomial space, okay, over real numbers real numbers. So now check that u, v and w are uh, linearly independent. So linearly independent, if you want to check, what you need to do for this, you need to calculate the Wronskian. So rather than writing them in vector form, what we will do, so we write here consider, okay, so consider u equal to f1 of x equal to 1, okay, v equal to f2 of x equal to x, and w equal to f3 of x equal to x square. Further, what you do is you have calculate w now. So w is basically what, f f1 f1 f2 f3. Then you have three vectors, so you do double derivative. So f1 dash f f1 dash, you calculate the first derivative, f2 double dash, you calculate sorry, just a minute, f1 dash, then f2 dash you calculate, and then calculate f3 dash, then calculate f1 double dash, f2 double dash, and f3 double dash. Let us see whether it goes down to 1 or not, or 0 or whatever it comes. So 1x x square, the first derivative is 0, second derivative is 0, here it is 1, here it is 2x, and the last one here it will be 2. Okay, so the determinant over here is equals to 2, which is not equal to 0. Therefore we say that f1 f2 f3 are linearly independent. Okay, these are linearly independent, hence and they are 3 in number, and so they will be the forming the polynomial space basis also. ये समझ में आया आपको? हेलो, जो लोग भी ऑनलाइन है वो आप बता सकते हैं आपको ये समझा कि नहीं समझा, क्योंकि दोपहर का टाइम है, थोड़ा थक गए होंगे। मैं तो खुद थोड़ा सा आज थक गया था, पर फिर भी वो लोग कमिटमेंट दिया था, बोला था कि लेक्चर रखेंगे तो लेक्चर रखना तो पड़ेगा। तो बोलो, तो आपको ये समझ में आया क्या? बेसिस का बात कर रहे हैं आज, तो बेसिस समझ में आया आपको? जो लोग भी ऑनलाइन है बता पाएंगे आप? हेलो, ज़रा कमेंट में आप बताएंगे आपको समझा? तो बेसिस चेक करना है तो क्या करना है, वेक्टर जो भी दिया है उसका डिटर्मिनेंट चेक करके बता दीजिए कि लीनियरली इंडिपेंडेंट है या डिपेंडेंट है। इक्वल टू 0 आया तो डिपेंडेंट, नॉट इक्वल टू 0 आया तो इंडिपेंडेंट। और अगर फंक्शंस दिए हैं, फंक्शंस हैं, तो f1 f2 f3 देकर उनका डेरिवेटिव कैलकुलेट करेंगे। Am I clear? Hello, those who are online, can you tell whether you have followed or not? हेलो, कमेंट में बता सकेंगे आप? हाँ, तो ये कमेंट हो नहीं रहा है क्या? पता नहीं, देखते हैं। पता नहीं कमेंट का क्या है। Yeah. So can you let me know in the comment? I think the comment section is on available. So समझ में आया आपको? कोई बता नहीं रहा है तो मुझे पता नहीं चल रहा है, ठीक है। बाद में आप बता दीजिएगा कमेंट करके कि आपको समझा कि नहीं। सो अभी ये इतना था। तो अभी अनदर इम्पॉर्टेंट टॉपिक विच आई विल बी interested in discussing is orthogonality of the vectors. Orthogonality of vectors. So see, in vector space what you say, let u u bar and v bar be two vectors in v over r, then u bar is perpendicular to v bar if inner product u bar v bar is equal to 0. Okay, is 0 bar. This is what does it mean. So basically your dot product becomes 0, but in a larger terms you say that uh, this way, the inner product is 0. Okay. All right. So here is the thing. So that is u and v are orthogonal हाँ okay, orthogonal if u bar comma v bar is 0. Okay, inner product is 0. So consider here um, so consider let's take up a question. Consider u and v. Okay, u and v as vectors in v equal to r3. Okay, so check whether they are perpendicular or not. Okay, check whether check that u and v are perpendicular or not. Perpendicular means orthogonal. Okay, so answer, so u equals to, if I take 1 comma 2 comma 3 and v equals to, I'll take some vector 3 comma minus 2 comma minus 1. So let us see whether they are orthogonal or not. So what you need to do is u and v, see, technically speaking it is not the way we are supposed to write, not this is not the way, but ठीक है चलेगा। तो अभी इतना भी ज़्यादा डिटेल नहीं है तो चलता है। 1 2 3 and then 3 minus 2 minus 1, you do the dot product, so it is going to be 1 into 3 plus 2 into minus 2 plus 3 into minus 1. Okay, so here it is minus 1, so answer is equal to minus 4, which is not equal to 0. Hence u and v are not orthogonal. Okay, hence u and v are not orthogonal. Easy. So okay, so that is one thing. Okay, yeah, now how to calculate the angle between the two vectors. Okay, write down here. So consider, calculate. So for calculating the angle between the two vectors, angle between two vectors u and v. Okay, so it is the formula is going to be like this. The formula is, say, you already have cos theta. So the formula is u over norm u norm v. This is the formula. So or you can take theta is equals to cos inverse of inner product uv over norm u norm v. That is there. And yeah, so let us see what is the angle over here. So consider, question is find angle between let's say u equal to 1 comma 2 comma minus 1 and v equal to 2 comma 1 comma 0. So what is the angle between these two vectors? So let us calculate the angle. So first is inner product we will calculate. So inner product is 2 1 sorry u 1 2 minus 1 dot 2 1 0. So that's going to be 2 plus 2 plus 0, that is 4. Then you calculate norm u. Norm u is square root of 1 square, 2 square and minus 1 the whole square. So that is 1 plus 4 plus 1, that is root of 6. Okay, and norm v is going to be 2 square, 1 square and 0 square added, so that is root of 5. Okay, so therefore cos theta is equals to inner product uv over norm u norm v. Followed this? Okay, so this will be cos theta will be what it is going to give you is 1 comma 2. Yeah, we have already calculated, right? So that is 4 over root 6 into root 5. So that is 4 over root 30. So theta is equals to cos inverse of 4 over root of 30. This is the angle. Okay, Okay, now another thing what is there here is after the angle between the two vectors, orthogonality between the two vectors, we will also have to see whether how to find a vector which is perpendicular to the two vectors. So see, if u and v are two vectors, this is a very common property. Two vectors in v, then u bar cross v bar is perpendicular to u, and u bar cross v bar is perpendicular to v, both the vectors. Okay, this new vector is perpendicular to both. So what you do is, so in exam they always they say find a vector perpendicular to u equal to 1 0 minus 2 and v equal to minus 3 2 minus 4. So we have to find a vector perpendicular to these two. So what is this is basically the cross product you have to calculate. So u cross v is nothing but I j k. Okay, I j k you take, and that will be your answer. So here it will be 1 0 minus 2 minus 3 2 minus 4. So here it is, what you will get is I multiplied by minus of minus 2 is minus 4, minus of j multiplied by, then that will be minus 4 and minus of 6. Okay, and then there will be k, a plus of k multiplied by minus of 3, minus minus plus 3. Yeah. Okay, so answer here it is minus of 4i plus of 10j plus of k, 3k, right? And all these are units, I hat, j hat, k hat. Okay, so the vector u cross v will be minus 4 10, and here it will be 3. Followed this, how to find a vector which is perpendicular. So the vector which is perpendicular, therefore u cross v bar is perpendicular to u bar, and u cross u, this one is perpendicular to v bar. This is what is important. There is nothing much about it now. Alright, so that's the most important thing regarding it. Now there is one inequality which is very popular, that is called Cauchy-Squash inequality. So Cauchy-Squash inequality. Okay, so what does this inequality do? It will, so if u bar, okay, if you have u bar and V bar as two vectors belonging to capital V over R. Okay, then uh, this inner the mod of the inner product U V inner product is always less than norm U into norm V, and yeah, this is what is there. So now consider here a very easiest proof. The proof I'll just give you for understanding purpose. Consider cos theta is equals to inner product uv over norm u norm v. Okay, so take mod on both the sides. So cos theta is modulus of uv over norm u norm v. Okay, now I'll just write here norm u norm v. I'm writing the RHS first. This becomes norm u norm v. Okay, and this is equals to mod of cos theta. Okay, now mod of cos theta is always bounded by 1. So yeah, bounded by 1. Okay, its maximum value of cos theta will be 1. So norm u norm v is maximum, rather this is maximum. Okay, this is maximum bounded by 1, so that means this value is maximum bounded by 1. So inner product uv is always less than norm u norm v. This is the proof, and hence proof. A very short proof, not very technical right now, but a good proof to go ahead with it. Okay, so got this? Those who are online, could you please let me know whether you followed the concept or not, or do you want to write anything that you had missed out in the previous part? Okay, fine. So we go ahead with this proof now, and yeah, we'll do one problem on Cauchy-Squash inequality, and I think then we can stop on this, and that would be and then we will see for the third video lecture in some another day. Okay, so so in exam most of the times they ask you verify Cauchy-Squash inequality. So consider u is equals to 1 minus 3 minus 2 and v equals to 0 to 7. Okay, so what you do is norm u is the square roots, right? 1, 9 and 4, so that is 14. Norm v is 0, 4, 49, so that's going to be 53. Now inner product uv, it is going to be 1 minus 3 minus 2 dot 0, 2 and 7. So this is going to give you 0, plus minus of 6 minus of 14, so that's minus of 20. Now it is very obvious that mod of uv is going to be mod of minus 20, which is okay, a mod that's going to be 20, and norm u norm v is obviously root 14 into root 53, and what you can see is here, that is 20 is less than or equal to root of 14 into root of 53. Therefore inner product uv is less than or equal to under the mod here, so less than or equal to the norm u into norm v. Okay, so that's how you verify. Hence Cauchy squares inequality is verified. Okay, so this is how you do the question in exam, like wherever they ask you. Okay, so this is what I had to share it with you all for today. So thank you for joining in. I'll meet you in the other class next time with the other detailed topic. Thank you. Alright, so any doubt anyone has, so you can ask me. Yeah, I think I had set up a duration a bit of longer length. Maybe I thought the topic would take some time, but I see we speeded up with very quickly because very few people are there, and all the few people are quite intelligent, so it did not took too much of time. So it's a great thing, and we have managed to worked out the entire thing within an hour. So thank you. So this is the thing that I had to share it with you. So today we have done Cauchy squares inequality with the proof, the orthogonality of the two vectors, then we saw cross product of the two vectors, the between the two vectors, and then what else did we see? We saw linearly independent thing with how to check whether something is basis or not. We saw these many results on basis and so many things. So quite a good amount of work we have done. So thank you for joining. I'll see you in the next class. So please let me know your feedback in the comment section so that I can sign off. Otherwise, if you have anything, we will discuss about it. आपको कोई डाउट है तो पूछिए, otherwise we will stop. पूछिए है कोई डाउट या समस्या तो बताइए कमेंट सेक्शन में. ठीक है, bye bye. So we will meet later some other day. Thank you.